So the next Greek we're going to look at is option Greek gamma. I've switched over to the SPY ETF because it's a little bit easier to see on this than with PayPal. So let's go ahead and open the 9th of September. I've added a second column here. This is option Greek gamma. So I have delta over here, and then the gammas are just to the right of it. And on the put side, I've added gammas over here. So if you remember from the previous video, gamma is the rate of change of delta. So it's a little bit tricky to understand, and gamma becomes more important the closer you get to expiration. But what it's showing you is how fast your delta is changing for every $1 move in the stock price. You can see that gamma is largest when an option nears at the money. You can see as it goes further out of the money, the gamma gets smaller and smaller. It's going from 0.03 to 0.02 to 0.01. And then in the other direction, it peaks at 0.04, and then it goes down to 0.03, and then down to 0.02. So delta has the biggest change when the stock price is near the strike price of your option. So how to think about gamma is that you are essentially adding this number to the delta. So 0.20, this is the delta for the 357 strike. To get the next delta, you would add 0.03 to 0.2, and that gives you 0.23. 0.23 plus 0.03, that's 0.26. 0.26 plus 0.04 is 0.3, and on it goes. So you may see some additions that don't add up quite correctly. That's because option Greeks are measured out to 4 decimal places. So some of these numbers are going to be rounded, so not all of them are going to be perfect. Like right here, this is 0.14, and then the gamma is 0.02. It's showing 0.17. That's because this gamma is actually bigger. It's just being rounded down to 0.02. So the other point to know about gamma is that it becomes bigger and bigger the closer you get to expiration. So let's go ahead and open something that's expiring very quickly. So the 31st of August, that's 4 days away right now. You can see that the gamma has increased. It's 0.09 now. About 2 weeks ago, it was 0.04, but now the at the money options they have a gamma around 0.09. And this is where option prices are the most jumpy, when an option is at the money and close to expiration. This is because there's uncertainty about whether the option will expire in the money or out of the money. So that's when option prices are the most jumpy, and you're going to see big swings in premium. I mean, so the 352 has a delta of 0.26, and the 348 has a delta of 0.6. So you can see that a mere $4 move in the SPY ETF results in almost a 40-cent swing in the delta. And that's not something that you get with an option that's expiring further away. So if I open something like 50 days away, you can see that the gamma is very small. It's 0.02, 0.02. Basically all of them are 0.01 to 0.02. So that is the important thing to know about gamma. With puts, it's the same concept, although it gets a little bit confusing with the negative sign. So what you're doing is you are still adding the gamma to the delta. So negative 0.25 plus the gamma 0.05 is 0.3. 0.3 plus 0.06 is 0.36. So you're still adding gamma to delta. The delta, it just has this negative sign to show you that the profit and loss is moving in the other direction. So it can get a little bit confusing with the puts, but the concept is still the same. It's still the same thing as with the calls. So that is option Greek gamma. And the next one that I'm going to discuss is very important. It is theta.